Hi, welcome to Varenya's Photon Online Educational Academy. This is Guntuka Srinivas. This channel mainly concentrates on the basic concepts associated with physics, chemistry, and mathematics related to IIT and NEET examinations preparation. In the previous sessions, we have seen about speed and velocity. Let us see in this session about the concept of acceleration. Acceleration. What is acceleration? Acceleration is simply defined as is defined as is defined as rate of change of velocity. Rate of change of velocity. Now, the clarity in the mind, acceleration is nothing but rate of change of velocity. Clear? Now, observe this statement. Acceleration. As we said, rate of change of velocity is written as a bar. It is a vector quantity. Notation is a bar, vector quantity, vector notation, which is equal to the change in velocity delta v, v bar. V is also vector by delta t, change in time. Change in velocity. Numerator is delta. Delta stands for change. V bar. Velocity is a vector. Change in velocity. Numerator divided by delta t. Change in time. Change in velocity by change in time is nothing but acceleration. Observe. This can be written as change in velocity. Let us say v2 minus v1, change in velocity, by change in time t2 minus t1, t2 minus t. Clear? No. Observe. Acceleration, I clearly write. Acceleration is a vector quantity. Is a vector quantity. Units are meter per second square. Other clarity. It is a vector quantity and units are expressed in the meter per second square. Example here I write. Example, if I write, suppose acceleration, a bar, vector quantity. If it is, let us say, 3 meter per second square. If it is 3 meters per second square, the meaning is that it can be written as 3 meter per second per second. 3 meter per 3 meter per second by second. That means for every second, there is a change of velocity of 3 meter per second. So carefully, if I represent acceleration a bar vector quantity as 3 meter per second square, it indicates that it can be written as 3 meter per second by second or per second. That means denominator, observe, denominator is second. Per every second, there is a change of 3 meter per second velocity. That is the meaning of acceleration. Clear? Now, clearly picturize this. Suppose, example, acceleration a bar is, just now I have taken 3 meter per second square. 3 meter per second. What is the meaning I told? For every second, 3 meter per second per second. That means for every second, for every second, for every second, there is an increase of, velocity of 3 meter per second. Here, for every second, there is a 3 meter per second velocity is increased. Denominator is per second, numerator is velocity. So, for every second, there is a change in velocity. 3 meter per second. Here, acceleration means the rate of change of velocity. Rate of change of velocity. Observe the same example if I take. When time is equal to 0, when time is equal to 0, when the body is at rest, the velocity v bar is 0. When time is equal to 1 second, as time increases 1 second, the velocity is increasing 3 meter per second. Time increases, the velocity is increasing 3 meter per second. When time is equal to 2 seconds, as time is increasing, again 1 second, that means time is equal to 2 seconds, velocity is increasing again 3 meter per second, that means 6 meter per second. When time is increasing 1 more second, when time is equal to 3 seconds, the velocity here, when time is equal to 2 seconds, the velocity is increasing 6 meter per second. When time is increasing 3 seconds, the velocity is again per second 3 meter per second. 6 plus 3, 9 meter per second. That is the velocity is 9 meter per second. Of the clarity. When time is equal to 0, body is at rest, velocity is 0. As time is increasing 1 second, for every second, we have taken an example. This is an example. For every second, there is a 3 meters per second velocity is increasing. So as time is equal to 1 second, velocity is increasing 3 meter per second. As time increases to 2 seconds, velocity is increasing 3 meter per second. Earlier 3 was there, now 3 added, 6 meter per second. When time is equal to 3 seconds, again earlier 6, now 3 meter per second, 9 meter per. That means every second, 3 meter per second, the velocity is increasing. That is the rate of change of velocity, acceleration. The meaning of acceleration is rate of change of velocity. Is it clear? Okay. Now, observe carefully that here afterwards, average acceleration, average acceleration, average acceleration, A bar, AVE average, AV stands for average acceleration, is simply defined as V2 bar minus V1 bar, change in velocity in the numerator by the change in time in the denominator, T2 minus T1. This is the formula. Average acceleration formula is this is the formula. Here, this is the average acceleration. Okay. Now, if we concentrate on the instantaneous acceleration, instantaneous acceleration. I underline instantaneous acceleration. Then A bar instantaneous. A bar instantaneous is simply defined as dv bar by dt, where dt stands for very small time change, dv very small change in the velocity. Yeah, within a when time becomes very small, then the change in velocity dv happens. Okay, this is the formula dv by dt. Instantaneous acceleration means at a particular acceleration at a particular instant of time. We have defined the instantaneous velocity earlier. What is the meaning of instantaneous velocity? Velocity at a particular instant of time. Similarly, acceleration, instantaneous also. Instantaneous acceleration is at a particular instant of time. dv bar by dt. Here, this is the formula. Observe, very small. That means here, this is the formula. This is the formula. Here, we know that average acceleration is delta v bar by delta t. Delta v bar by delta t. When delta t, change in time, becomes very small, almost zero. When delta t, very small. Here I clearly write, very small. When delta t, change in time is very small, almost equal to zero. Then delta t becomes dt. Delta t becomes dt. Delta v becomes dv. That means this leads to A instantaneous. Okay, right? That means dv bar by dv bar by. Yeah, when change in time it becomes very, very small, then delta t becomes very, very small. That small time we represent as dt. Within the small time dt, small change in velocity is dv. At that very, very small interval of time, we say that it is instantaneous velocity. Average velocity definition changes when delta t becomes very, very small as instantaneous velocity. Is it clear? Okay. This is valid only at a particular instant of time, when time period is very, very small. Clear? Now, observe. In the earlier classes, we have seen that velocity is v bar, which is simply ds by dt. ds by dt, instantaneous. ds means very small. Instantaneous velocity is ds by dt. Now, we are getting this velocity from when we draw. Here I clearly write. When we draw displacement versus time graph. When we draw displacement versus time graph, that means S T graph, here ST graph, the slope of ST graph, is velocity. We have seen in the previous session, the slope of ST graph is nothing but velocity. This we know from the earlier concepts. Okay. Now, we are concentrating on the acceleration. If we take up acceleration, that is instantaneous acceleration, bar instant, which is equal to dv bar by dt. For a very small period of time, when time is very, very small, change in velocity in that very, very small interval of time is known as instantaneous velocity. Rate of change of velocity within that very, very small interval of time is known as instantaneous acceleration. Clear? This instantaneous acceleration, okay, as we define, here I highlight, when we draw velocity versus time graph. Velocity versus time graph. That is VT graph. Is VT graph. The slope of VT graph. The slope of VT velocity time graph gives acceleration, gives acceleration. Have the clarity. It gives the acceleration. Slope of VT graph gives acceleration. What we have seen earlier, we have seen if we draw displacement time graph, the slope of displacement time graph gives velocity. Similarly, when we draw velocity versus time graph, the slope of VT graph gives acceleration. The slope of VT graph gives acceleration. Clear? Okay. Now, observe. Here I am showing two examples.